So to look at the different evaluation metrics for a classification scenario, let's leverage one of the examples we have used in our previous slides. So I'm pointing towards the HR comma data, HR dataset, which is the HR analytics dataset downloaded from Kaggle. So we built a classification use case, which was the churn model, trying to predict when will an employee leave the organization. So I'm leveraging the same data set. I'll build a logistic regression model. I'll predict the outcomes. And then we try to see how we can calculate the different evaluation metrics. So it's the same process that we had previously. I'm importing the data set and I'm looking at the shape and the columns. So let's say here we have 14,999, approximately 15,000 rows and 10 columns. These are the column names. Now I'm importing pre-processing and the model selection function train test split, similar to what we have done in linear regression. And I'm leveraging the same function, that is label encoder, to convert a categorical variable into its one-hot encoded format. Again, I'm separating the categorical variables. I'm also separating the target variable, and I'm separating the numeric variables. So these three variables, I have one set of categorical variables, one set of numeric variables, and finally I have a target variable. And I'm finally using the same process to create a combined concatenated dataset of all numeric columns and one hot encoded versions of each individual categorical columns. So as you would expect the size of the new data frame to expand. So now we have 20 columns. And if you look at the column names, the numeric column names remain the same. But then if you see the categorical columns like sales, now we have sales underscore sales, sales underscore support. So for each sales underscore technical. So for each distinct class under the categorical variable sales has now an individual column with a binary flag. And same holds true for salary. So you'll have salary low, salary high, salary medium. Yeah, there we go, and so on. So now we have we have a combined data set with all the predictors under one roof. Let's use the train and test split function to create the train and test data sets. So now let's import the logistic regression function. So from sklearn dot linear models, we'll import logistic regression. There we go. Let's create a model. We'll say model is equal to logistic regression that instantiates an object, and we'll say model.fit, and we'll pass x and y. So in this way, we have created a logistic regression model, and we have fitted that for the training data set which we have. Now we need to see how does it perform on using a couple of evaluation metrics. So let's create the prediction variable. So this is y underscore pred, which will be, let's say, model.pred and predict, and we'll pass the test data set. So that will be x underscore test. So now we have the predictions for the test data set under y underscore pred, and the actuals of this will be stored under the variable y underscore test. So y underscore test is the actuals, y underscore pred is the predictions. Now you don't need to actually codify Python functions for each of the evaluation metrics we just discussed. You can just leverage the same package, that is sklearn.metrics, and you will import a bunch of different metrics over here. So you will say accuracy score. This is the function that will give you the overall accuracy. Then you'll have precision score. You'll have the recall score. Then you have the confusion matrix is also important. So we'll say confusion matrix. Then we have the ROC curve and the area under curve value. Let's add ROC underscore curve and AUC underscore ROC. We'll take this later. We missed out one thing, which is FN score. So let's import them and see what are the different values for different metrics. So let's take the overall accuracy. So we'll say accuracy score of y underscore test and y underscore pred. How does it look? So we have around 79% accuracy. Now this looks great, which you can roughly say around 80% of the predictions made are valid. But if you would just contemplate on what kind of use case we are dealing with attrition dataset. So generally in an attrition dataset, the dataset will be imbalanced, which means that you'll have the actual class, that is employees leaving, as a relatively lower number. So let's say out of 100, around 30 to 40 would actually be leaving the organization, or even lesser than that. So 79% accuracy might not give us like a overall good picture. So let's say we'll explore using the confusion matrix. Use the confusion matrix and we'll pass the same value, y underscore test and y underscore pred. Now these are the values which you will see which we have for the use case. So this will be the actuals and this will be the predicted. Now if you want to clearly understand which of them corresponds to 0 and which of them corresponds to 1, you can just check by doing a double check on the y test variable. We'll say y underscore test dot value counts. Alright, we'll take the data frame itself, which is df, and we'll say left value counts. So 1 is the lower value, which means that the number of employees who have left, that would be 3571, which is a lower number. And if you do a simple check, this number is approximately more than 3 times of this number, or approximately 3 times, right? So now if you do a check over here, and if you look at the confusion matrix over here, you can see this would combine and give you the values for ones, like they're relatively lower in number. So if you take a closer look, and you can clearly understand that this would be 1, so this would be 0, this will be the ones predicted as 0, and this will be the ones predicted as 1. There's a significantly lot of values over here which are incorrectly predicted as 1. So let's look at the precision score and the recall value. So it's a precision underscore score, and in fact, rather than typing it all the time, let's just copy this. I say, yep, here we go. Now we have 57% precision rate, and let's say recall score, we have 33%. So here, this will help us understand in a much better way how precise and how the precision score and the recall value together, we can understand how good the model is from a deeper view, rather than just looking at the overall score where you have an unbalanced data set. Looking at the precision score and the recall score, you can fairly understand that this model is not performing really well in specifically the area of interest you have. That is, specifically interested in understanding the attrition of an employee. But in that scenario, it's not really giving you a great prediction. So let's move on. And there's one more thing, I just forgot about it. So we'll say the F1 score, and let's pass the value. And we have 0.42, which is 0.42, which is 42%. So F1 score is used to study when you want to combine precision score and recall score together. Now, we need to understand how we can look at the ROC curve. Now, there isn't a direct method to actually go and create an ROC curve or plot an ROC curve. So what you would do is you'll use the ROC curve function. You'll pass again the values y test and y pred. Now this returns the false positive rate, the true positive rate, and the thresholds. So it returns 3 different values. So we can leverage these values to again go and do a plot. So we say ROC curve and you check the false positive rate. You have the values for false positive rates. We have the value for true positive rates, and we have the thresholds also. Now let's say we'll import matplotlib's plot function. As plt, and we'll say plt.plot, and we'll say fpr and tpr as let's say as b. Let's see how does it look. It's a blue line. Now we'll just add one more thing. We'll say plt.plot, and we'll plot the baseline, which is 0, 1, and again 0, 1, and let's say we pass this as a dash. together. So the way we understand this would be there is a lift from the baseline, and that lift is not really significant. So this model is not really a great model. Now this model would have been a great model had the curve been somewhat like this. So the lift from this baseline, if it is higher, that would indicate a much better model. So this is not a great performing model. From the model performance metrics, you can understand that this is a very average model. There's definitely a lot of scope to improve this further and build a more powerful and more accurate version of this model. But in the ROC curve, just with a simple visualization, you can actually understand how good is this model from the baseline. Now, one additional feature functionality of the ROC curve is, let's say you have two different models and you want to plot both of them together. So let's say the first one comes over here, the second one comes over here. You can clearly identify using different colors which model is performing better than the others using a simple visual at one point of time. Now, similar to this, you can also understand whether your model is overfitting or underfitting. So these terms might be new, overfitting and underfitting. We'll pick up these very soon, but then just keep it in your mind. Using the ROC curve, you can also understand whether your model is actually overfitting or underfitting. Now that was a basic about ROC curve. We can also use the function to understand what is the area under curve. That will be given as ROC underscore AUC underscore score. So we will say y predicted and y test. Let's just import this first. Now let's run this function. And we have the area under the curve. Simplified one simple metric to understand how good is the model. So going back to our slide, we have understood the confusion matrix. We have understood the different terms that form the confusion matrix: true positive, false positive, true negative, and false negative. Now, based from the confusion matrix, we can derive a couple of different metrics that will help us understand how is the model performing. So we have the overall accuracy. If we go one step deeper, we have precision and recall, and we have a combination of two to combine together forming the FN score. There are also a couple of measures which you've not mentioned over here, which is the true positive rate, the false positive rate. I would highly recommend you to explore this in your free time. Lastly, we looked into the ROC curve and we kind of built a rudimentary plot along with the area under curve. Now this is a more fancy version. I would highly encourage you to add labels and make it more neater. You can embed the label over here and make it look overall a much better plot. So that's how we evaluate classification models. Now we have also talked about clustering models in the previous section. Clustering models is a part of unsupervised learning. Now, there aren't really any robust mechanisms or methods in place for understanding how we can evaluate clustering models. The most basic one identified or widely used is trying to see whether clusters have formed groups based on the original data set when you have labeled data. Now, for this use case, you need actual labeled data to go ahead and compare and find out whether it has come in alignment with your business requirements. But then in reality, you'll never have the luxury of labeled data. And if you have labeled data, you won't really go ahead and do a clustering use case. So that kind of becomes a problem. So there are no direct measures, but then there are a couple of measures available to understand how we can evaluate clustering methods. I'll leave it up to you. In your free time, I would recommend you to please explore what are the different evaluation metrics used for an unsupervised method like clustering. So that's it from this section. Let's move on to the next topic.